Very good evening, guys. Hope you people are very doing well. And today I am just taking the part of the pandas. And panda has a very important role in the data science field and how it works and how we can take the advantage of the pandas in the data science field. Let's see some program, and then we can easily understand and how it can be applicable on the data science field. Panda is basically very fast, it's very powerful, it's flexible and easy to use open source data analysis and manipulation tool built on top of the Python programming language. Basically, we can do the data object for data manipulation. Basically, we can do the manipulation of the data through pandas. And we can read the CSV file as well, SQL and database as well. Then we can easily see that Panda is well intelligent data alignment and integrated handling and missing value. And it can easily manipulate the messy data into an orderly form. Then we can do the reshaping through pandas. We can label them, slicing them and indexing them. And columns can be inserted and deleted from the data. So plenty of different kind of the things it can be done by the pandas. Now, creating pandas series from numpy array and dictionary. How we can do that? At first, we have to be imported the pandas. How we can import it that one? If your system doesn't have the pandas, then you can just run the terminal, and after running the terminal, you can just write down there pip install pandas. Then you can just enter it and the pandas will be automatically downloaded in your local system. Then to import that one, we just write down that import pandas as pd, and that is the import numpy as np. So pd and np, these are the standard way to write down the code, and we just run the program and we can already imported the numpy and the pandas. And to check the pandas version, how we can check that? We just write down the print, then pd dot underscore underscore version underscore underscore. If we run that program, then we can see that we have the pandas in our system, that is the 2.2.3 version. Then we use the random.randint function. How it works? Random.randint. And in this function, we just pass 10, 50, 5. That means the starting point will be the 10, and in between 50, they will take 5 means they will take at least 5 values. It can be any values. The system will decide that which values it will be taking. If we run that program, we can see the 16, 33, 38, 32, 30, 13. This all value comes under 10 and 50. If we run the program again, the value is automatically changed. Why it changed? Because machine is automatically has their own algorithm, so they are taking the value in between 10 to 50. And how many value they are taking? The 5. You can see here 1, 2, 3, 4, 5. Then if I check that variable, which kind of things is that? It is a numpy.nd array. Then series is equal to pd.series data. We are just passing this data inside this series, and after that we just print out the series variable. And if we run the program, we can see these all variable 27, 17, 38, 21, 26. This variable already passed here. And what is that? 0, 1, 2, 3, 4. These are the by default index value. How it comes, I'll discuss it in the next program. So let's see. So after that, I just check the type and I just pass the series. When I just run that program, we can see, yeah, this is the series. And guys, one more concept it will become later on. What is the difference between the series and the data frame? In the series, just remember guys, in the series, always there is the one dimensional array will be there. Or you can say, in the series, 1/3 bracket they will use it. And in the case of the data frame, Maybe the single column, it can be data frame. Maybe this can be data frame, but in the data frame, when you see there is 2 third bracket or the 2 square bracket, that is basically the data frame. And when you see that only 1 third bracket or the 1 square bracket it is there, then in that case that data frame is basically series. Guys, remember this small difference between the series and data frame. Sometimes the interviewer can ask the question, what is the difference between the series and data frame? Now we can do some operations in Pandas series, and series within third bracket, within square bracket, we just pass the 4. 4 is basically the column. Sorry, 4 is basically in the 4th position. What is the value? If we want to know that one, so in that case, if we just run that program, in the 4th position, 26th is there. If we want to know the 2nd position, that is the 32, then we just pass the 2nd, and if we run the program, then we can see 38 is the value. 30 in the 2nd position, 38 is the value. So that's why they are giving the value is 38. Now we can pass the one condition. Series greater than 20. It means whatever the value it comes under series, if it is greater than 20, in that case all the value will become the true. If it is less than 20, that will give the output false. Basically in that case the Python is giving the boolean value true and false. See, let's run the program. See, in that 0th position and 2nd, 3rd, 4th, all the position is all the values greater than 20, so that's why they are giving the true, and the first position, that is the less than 20, that is false. Let's see, you can see it here. Only the first position, it is the 17 is less than 20, so that's why they are giving the false, and rest of all the values you can see 0th, 2nd, 3rd and 4th position, all the values these are the greater than 20. So in that case, in everywhere they are just print the true, and the first place they are print the false. Now another condition, we are checking that search a value greater than 20. So in this way we can just write down the series within square bracket, series greater than 20. If I just run that program, we can see that in except first position, 0th, 2nd, 3rd, 4th, all the values are greater than 20. So that's why they are giving all the values here. If we do not write down this series, if we just write down the series under greater than 20, in that case they will pass the boolean value. If we pass the series and after that we just write down within third bracket series greater than 20, so in that case the Python will give the values output, and this is basically data type is the integer. So that's why they are just write down data type .int64. Now I already discussed about the data frame. What is the data frame? In earlier I already discussed that in the case of the data frame we can check it that there will be 2 square bracket or the 2 third bracket will be there in different color. But in here we are creating data frame from dictionary of Pandas series. We are just passing the dictionary. How we can pass that? Within data1 variable we just pass the key value pair, name, age, city, these are the key, and after colon these are the values. In the name key, Akshat, hello and world, these are the values of the name key. 25, 30 and 35, these are the values of the age key, and CHD, Punjab and Delhi, these are the values of the city. Then if we print the data 1, then we can see that they will just create this kind of the data frame as well. So in that case, when we just write down the one function, this is basically they are creating, this is the dictionary. This area they are creating the dictionary. To transform from dictionary to data frame, we are using here, write down here, pd.dataframe. Basically this function, what they are doing, we are just passing the data 1 inside the data frame, pd.dataframe function. When you just pass it and when we just write down the print df1, then in that case all the values, these all values transfer into the data frame. How it can transfer? All this name, age and city, these keys become the column name, and by default the index is basically they are taking 0, 1, 2, and rest of the all values means this value, and this value. All the values, they are creating the data frame. Now you can easily understand the keys become the column name, this one, name, age and city, name, age and city, and this index comes automatically by default. Now I just write down, just try to understand guys, this two line first. We just import the numpy as np, then we just write down within data variable. We are just passing the dictionary kind of things, key value pair. Within a and b key, we just pass pd.series. We are just passing the series. How we can pass that? Within first bracket, purple color first bracket is there, np.random.randint. I already discussed in the first program. Random.randint function, what they are doing, we are just passing three values, 10, 30, 5. That means the machine will automatically create the values. Third variable is the 5. Machine will create the 5 values. That values starts from 0 till 30. Any value it can be created automatically. The random means random.randint, basically they are doing, or the machine will create the different. If you run the 5 times of this program, machine will give the 5 times different number, but that number of course it will come inside the 10 and 30. And this function in the second line within b.pd.series np.random.randint 5, 8 and 5, that means they will generate within 5 to 8 the 5 values. You can see it here in the a, in the 0, 1, 2, 3, 4, these are the index, and they are generating within 10 to 30 5 values they are creating, 22, 10, 25, 19 and 27. And this is the data type of integer 64. And again in the b series you can see 0, 1, 2, 3, 4, these are the index number, and within 5 to 8 the machine are generating the 5 values, that is the 7, 5, 7, 7, 6. And in the last, in the c, and let's understand this one, we are just passing with key within c key pd.series 5 index 0, 1, 2. This is basically the array. They are passing that in the 0th position and the first position and the second position, just use 5. So in the C series, you can see in the 0th position they are passing 5, in the first position they are passing 5, and the second position they are passing 5. So in this way we can create some data frame as well, and we can, if we want to, do not want to use any random.randint function, if we want to manual give the number, fixed number, so in that case we can pass this number and the position as well through array. Now we are just checking the data type. This is basically numpy.nd array, this one. Now we are just using again the pd.dataframe. So we want to transfer all those data into the data frame. How we can do that? By using pd.dataframe function. Within this function we are just passing this data variable in here. Then if we print this variable df, then in that case we can see, all the data, all the 0th position 27, 17, 38, 21, 26, this one is created. How it created, you can see we are just created this one. So in this way probably they are taking this creating the one data frame. So just guys remember one thing, data frame, the one single column, it can be data frame, it may be the multiple column, it doesn't matter. But in the series it comes the one column. Now it shows throws error because I have to run all my previous program. Let's run all those things from the first. Here you can see that I already explained here in the data, in this data I am just passing all these values. I am just passing all these values, and they are creating. They already create this kind of the data frame. And after the data frame, if we want to print the second and the third position and the B column, then this value it will come. How it comes? I am using here the df.lock function. Basically, how the lock it works. Again, I already explained you the difference between the series and the data frame. Right now I am just going to explain about the lock and the iock function. Lock function is basically, if you want to take the exact name A, B, C or 0, 1, 2, if you write down the exact name, they are taking that exact value, the lock function. And in the iock function, basically I stands for index. So in the case of the iock function, basically they are taking the index number. According to the index, iock function is working. So guys, this interview question again, they can be asked in the data science interview, that if you, what is the basic difference between the lock and the iock? Lock is basically as taking the exact name. It may be the row name or the column name, but in the iock, basically they are taking the index. So in here I am using the df.lock function. I am using 2:3. That is basically the row. The first one is the row and the second was the column. Which row they are taking? The second row and the third row. This is basically the name, and B is basically, this is the column name. In the second row and third row in the B column, 5 and 6 is there. So if I run that program, then we can see that we are getting the output of the 5 and 6. Then after that, I just run that program here, and within data2 variable, I am just passing the key value dictionary. That is within P, I am just passing the 2, and Q passing 4. This is the first dictionary I am passing here. In the second dictionary, I am using three key value pair. I am using passing P, Q, and R. And when I just try to create this variable into the data frame, you can see pd.dataframe, I am using this function and I am just passing data to this variable. Then in that case, we can see that pqr, these all key pq, this one first two. In the second dictionary, we can see pqr, 3 keys there. All the keys there become right now the column name, and by default I have the 2 rows, so they are taking the 0 and 1. And after that, we see that 2 and 4. This one is the 2 in the P in the place of the 2, and the Q is place is the 4 value. P, the 2 is there, and Q 4. Then in the next dictionary, you can see in the P the value is 5, so that's why they are taking the 5 value. The Q, the 10 is there, the 10 is there, and the R, they are taking the 15. So in that case, in the first dictionary, you can see the R is not available. So that's why they are passing one value, that is the nan value. So if I want to change the index name, and earlier we can see that by default they are giving the 0 and 1 is the index name, but if we want to change according to our choice, then we can see we just write down the 2 variable name. It can be anything, whatever you like. That is, I am using right now the PyData one, and second one is the Explorer. So if I just use this data frame, and if I just run that program, then you can see that PQR, earlier it was there, all the column name, it is there, the column name is remaining same. In this way, we can change index is equal to, within third bracket or the square bracket, I am just passing 2 name or the 2 variable. One is the PyData, another one is the Explorer. So that's why they are taking these 2 value in the index position. Then if we want to change the name of the column, earlier we can see that our column name, it was there P, Q, R and R. So if we want to change the column name, how we can do that? I am just again using the same function, pd.dataframe function. Within that function, I am just passing the data2. Data2 means all the this data2 variable. I am passing all the variable, all the values I am passing here, and passing here, and then I am just passing the column is equal to P and Q. So in place of the PQ, in the place of the PQ, I am just write down the PQ again. So if I change the name here, suppose I am taking the A and B and run the program, you can see guys, you can see here all the column name are changed. All the column name are changed here. So basic functions are the operations on the data frame. How we can do the basic sum functions, we can see extracting a column from the data frame, how we can extracting the value from the column name. If we run that program, that n is equal to df, a is basically within square bracket, yellow color square bracket, I am passing the a is basically the column name, and I just write down the n variable, and if I just print there, if I run the program, we can see that my first data frame, it is there. This is basically the data frame. Within a 26, 13, 12, 16, 15, the variables are there, so that's why they are giving this variable 26, 13, 12, 16 and 15. Then if we want to print out the data frame, you can see that two brackets are used here. So in here, if I run that program, and if we want to trace all the A column and the B column, so I am just passing A comma B. So in that case, if I run that program, then we can see we just passed all A and B variable. So in that way, from any data frame in the industry, any of the column, if you want to trace, so in that case it is applicable for that. Now we can see we are just type n1. N1 is basically this variable. Which kind of data is there? This is basically data frame. I already explained there. In the data frame, you can easily understand there will be two square bracket, yellow color square bracket and the purple color square bracket. So you can easily understand this is the basically data frame. And in n, this is the series. Which one is the n? This is the basically the n variable. In n, you can see there is the one square bracket. So basically one square bracket gives you the one series. So when we are checking the type n, that basically gives the output, that is the series. Now extracting two variable or two columns from data frame, how we can do that? Or we can take the 3 variable in the column, the 4 variable, 5 variable, it doesn't matter, whatever our requirement in the industry. How we can do that? We just take the one variable, that is the p. Within p, I am just write down the df data frame basically. Then I am just passing two square bracket, one is yellow color and one is purple color, you can see here. Then I am just passing the column name a within first inverted comma, B within first inverted comma, and C. Now if I run the program, if we just run the program, then we can see that we just get the A within A column, all the value I got it, and with the B column I got it, all the values, and C, all the values I got it here. Then after that I just check the P. I already told you that if you see the two square bracket is there, so in that case of the double square bracket, that is basically the data frame. So I just take the previous data frame here, I just print it here, and after printing here I am just using df.log function. Log function is basically told you that they are taking the from 2, this is slicing, how they are doing that, 2 till end, means they are taking from this 2, so this second row till end, this fourth row is the till end. So if I run the program, you can see these all values they are giving the output here. That is basically there's the slicing according to the row wise from the second till end. Second is not the position, basically this is, you can see it by the name they are taking it. The log function is basically taking the name second till end, nothing is there, that it means till end. So from the second till end they are taking all the values. Then df.log2, log2 is basically extract an element from data frame using row index. How we can do that? I am just passing that within log function, that's the second position. Which is the second position? These all values are there in the row wise in the second position, 12, 5 and 5.0. So if we just pass within one square bracket that position name by using df.log function, so they will pass the 12, 5 and 5, these 3 values, these values. Then extract an element from data frame using row index and the column index. How we can do that? I am using this one, is the first one is the row and second was the column name. How we can do that? If I just write down this program, we can see in the second position B column. In the second position B column, this is the second position of the row and B is the column. This is the value is the 5. So that's why they are giving the value the 5 here. Now slicing multiple elements from data frame using row index and the column index. How we can do that? This one is basically the row index and this is basically the column index. And in here df.log function basically says 2:3. They are taking second row and third row, comma, second column, B is the second column, or the column B is to C, column C. Basically they're taking second and third row, this second and third row, and B and C, this is basically these two column. So in the second row and third row they are giving the output 5, 5.0, 6 and 9. See, 7, 5.0 and the 7, 9. Then slicing multiple elements from the data frame, how we can do that? I am using again the df.log 2:blank. If I just run that program, you can see already from the second position till end position they are taking. Basically this is the slicing, and basically they are taking the by using the log function. This is not the slicing, this is basically taking the exact position value. This is the row position, second and the third row I am taking, and the second B column and C column I am taking. But in here, this is basically the slicing part. That is the basic difference to extract the data from exact by calling the exact name of the row and column, or you can slicing in this way. Just passing one square bracket, and within that I am just write down the row and column name, and then I can extract the value. Now I just use the one data frame here, df5. I am using the pd.dframe. I am using these values. How we can understand this is the data frame? You can see in here the purple color and the blue color third bracket is there, and within that I am just passing the three arrays 4, 7, 10, 5, 8, 11 and 6, 9, 12. Then I am writing that index is equal to 13, 14, 15, and the column name should be the ABC. Then after that, if I run the program, we can see the force this value always create one data frame. This value are creating data frame, and column name ABC, they are using the ABC column name, and the index number 13, 14, 15. That's why this is the index position. They are using 13, 14, 15. Guys, if we are not writing anything about the index and the column, then in that case basically program just give that by default the column name starts from 0, 1, 2 and the index number also starts from 0, 1, 2. So instead of using 0, 1, 2, if I want to use any particular name, so by using index is equal to this array, single array, or column is equal to ABC, we can use according to our choice the column name and the row name. These are the column name and these are the row name, means index name. Then I am just passing the same thing. In here you can see that I am using here only one index. Index should be 13, 14, 15. You can see 13, 14, 15, and we are not passing any column name, so by default they are taking 0, 1, 2. Again I am just printing that previous data frame. ABC column name is there, 0, 1, 2, 3, 4 index is there, and different kind of the values are there. If I just write down the df.log function, log basically just giving you the exact position name, the row or the column it might be. The first is basically the row name. They are taking 0 and 1 row, and B column and C column. You can see the 0 and 1 row, B and C, the value is 7, 5.0, 7, 5.0. So that's why they are giving the output 7, 5.0 and 7, 5.0. Then if we are checking the data frame, basically I told you that if the value is more than one column, then the basically this data frame is the type is the data frame. So that's why they are giving the output, that is the data frame. In here guys, I already passed the ABCDE. What is that? I am passing the one dictionary here, the key value pair. So if you are passing one dictionary, just in that case guys, remember all the keys become A, B, C, D, E, all the keys they are becoming the column name. Index by default the system can take 0, 1, 2, 3, 4. But here I am passing the index is equal to 10, 2, 3, 4. Suppose it can be anything. It can be 5, A, B, C, D, RAM. If you want to use any particular name, RAM, Sita, anything, you can pass it there. So if I just run the program, you can see that these all keys, A, B, C, D, all keys, they are becoming the column name, and this index is basically 10, 2, 3, 4. These are becoming the index 10, 2, 3, 4, and rest of the all the values, this one, this one, this one, this 5 row, these all values, they are creating this data frame. And these are the index. The left hand side, these are the index, and these are all the values from there. And how we can change any column name. Suppose I am not liking this column name. Suppose I want to change, instead of using C, I want to change it into C1. How we can do that? If we are using the df8.rename function. Basically rename function does change the column name, and within rename function I am just passing here columns is equal to within curly braces or within second bracket C I am passing it. I want to change this value. So whatever the change, if you want to change it, this value you have to write down the first, and that what name you want to use it, that name it should become later on. So if I just run the program, you can see the earlier that column name it was the C, and here right now C1. Guys, remember one thing, in this program, if we do not write down in place is equal to true, so in that case this change is not permanent. This is basically the data frame is remaining same. For our operation, we can just change in our data frame in the local system, but data frame is remaining same. But in the next program, you can see in the df8, see there is no change of the name. The column name is remaining same. But if we want to change permanently of the column name, how we can do that? I am using the simple two word I am using, that in place is equal to true. I am just writing here that in that case, if I run the program, then you can see then the previous data frame name is changed now. So if you are not using in place is equal to true, so in that case the change you can be observed here. The change you can be observed in here C1, but it is not permanent. So to change any column name or the row or index name, so you have to write down in place is equal to true. So in that case the data frame name is changed right now permanently. Then I am using the sort underscore values. That is the another kind of the function. Basically sort means you have to there are two kind of sort. One is like the ascending order, one is the descending order. Ascending order means small to bigger value, descending order means bigger to smaller value. But order rows by values of a column higher to low, that means descending order. So you can write down the descending is equal to true, it can be happen, or you write down the ascending is equal to false. That basically means descending. Ascending basically is equal to false means that opposite is descending. So if you run the program, you can see in the C1 column all the values just take the descending order 9, 9, 8, 7 from bigger to smaller. Now the most interesting part comes here. You can see or you can observe 2 9 is there in the data frame. That which 9 then comes in the first positions. So basically in the data frame, which 9 is basically positioning the first, they are taking that one in the first position. That means this is the original data frame. In the original data frame, this row comes the first. This row comes first. So they will take this row first, and this is in the second position in the original data frame. So that's why this row will comes in the second position. This row comes in the second position. Here guys, just remember I already discussed a lot of things about the lock function. Now we can start about the iock function. I already told you iock is basically I stands for index. So in here, select column in positioning 1, 2, 3, 1, 2 and 5. First column is 0. So how we can do that? I am just passing df8.iock function, and I am just using that within third bracket or within square bracket, and nothing I am writing here. Within colon I am not pushing here. That means in the row I am taking all the row. There is no starting and the ending. That means all the data frame row they will taking it, and which column will they will take. This is the basically the column. 2 will be included, 3 will be excluded. So basically they will take that one column, that is the second column. So that's why you can see it. Which one is the second column? This one is the 0, first, second, third, fourth. So basically they are taking the second column, this one. So they are giving the output of this one. So in this way we can slicing the data frame by iock function as well. So the basic difference between lock and iock is that lock is taking the exact name and iock is basically taking the index number. So again I am passing the one iock function. I am not passing any row position. That means they are taking all the rows, and after that I am taking that 1, 2 and 3 column here. Which one is the 1, 2 and 3 column? These are, you can see, these are the 0, 1, 2, 3, 4. So I am passing 1, 2 and 3. These are column. So we are taking the B, C1 and D. This column that we are taking it here. But earlier the basic difference between here and here, I am passing here one array. Array is basically in the slicing part, you can see in the column position we are taking the second position and the last position always excluded. So that's why we are taking this one. But when we are passing one array 1, 2, 3, in that case they will not excluded the last position. They will not excluded the last position. They will include all the things 1, 2, 3. So that's why they are just giving the output of the B column, C1 column and the D column. Then again I am using the df8.log and df8 I am just passing the B column and that is greater than 5. Then again passing one condition B comma C1 column. So what we exactly try to do by writing this program, basically selecting rows meeting logical condition and only the specific columns. How we can do that? By writing down the dot column df8 I am just passing the data frame. And in this data frame, I am taking only the B column. Within a square bracket, I am passing B within single inverted comma. Then I am giving the condition that is greater than 5. That whatever the value in the B condition, whatever the value of the B column, that should be, if any value is greater than 5, so just take that value and then I am passing B and C1 column, B and C1 column. So they are checking that which value are basically greater than 5 in the B and C1 column. So they are passing it here. If I run the program, you can see in the B column is greater than 5. That is this 6 and the 8 and this 9 and this 9. Why they are not taking 7 and 8? Because I am writing down the condition. The first condition is that it should be the greater than 5 of the B column. So in the B column they are finding third and fourth row, this third and fourth row. After that they are checking that this first, third and fourth row in C1 column, this is 9 and 9. Yep, these are the values are greater than 5. That's why they are just passing these two value. But why it is not there? Because in the earlier you can see in the B column 4 and 5 is not greater than 5. So that's why they are not taking the 7 and 8 value of the C1 column. So first they are checking this condition, then they are matching whether that C1 column is basically these two values 9 and 9 is greater than 5 or not. That's why they are just taking the third and fourth row here and they are giving the output, this 4 output. Now statistical operations on the on Pandas data frame. How we can do that? I am just taking that data frame here. These are the row name A, B, C, 1, D, E and 10 to these are the index number 3 and 4. And after that I am just calculating the mean function. Mean is basically giving the average. How we can give that? Basically if I am not writing anything, axis is equal to 0 or the 1, by default mean it works in column wise. So how we can do that? In the A column 1, 2, 3, 7, 1 plus 2 is equal to 3, 3 plus 3 6, 6 plus 7 13. 13 divided by 4 is equal to 3.25. In such a way they are just column wise they are taking all the values, they sum up all the values here, then after that they are giving the mean value. In the same thing, if we want to do the row wise, so in that case I have to write down axis is equal to 1. If I am writing down the axis is equal to 1, in that case they will check that in the 10th row they will just sum all this value 1 4 7 1 8, 1 plus 4 is equal to 5, 5 plus 7 is equal to 12, 12 plus 8 is equal to 20, 20 plus 1 is equal to 21, 21 divided by 5 is equal to 4.2. In such a way they will just give the mean value. Then df.sum, again if I am writing down nothing, axis is equal to 1 or 0, so by default they will do the column wise. If we want to do the row wise, the sum function, the same thing, I have to write down axis is equal to 1. How we can find out the missing value in data frame? How we can do that? If I am using df.isNull function, so in that case in data frame, original data frame, so if there is null value, then they are giving the boolean output, that is the true in this true position. So there is no value, so that's why they are writing down the true, and rest of the places all there they are using the false. You can see it here. This is the data frame. In this position, third and the fourth position, there is no value, so that's why they are giving this two position true, and rest of the things they are giving the false. Then suppose the data frame is huge, so we don't have time to check whether the value is missing. Then if we count it, if we want to see at a glance that how many values missing in our total data frame, then I am using df.isNull.sum function. If I just write down, if I just run the program, then we can see that in the A position there is no missing value, B position there is no missing value, and C position you can see that there is two missing value. In the A column there is no missing value, B column there is no missing value, in the C column we can see that two missing value is there. In such a way we can easily identify that which column we have the missing value. And if we want to drop, any or drop columns basically with missing values, if there is any column is the missing values, then if we do not want to take that values, so how we can do that? We can use df.dropAny function. If I just run that program, you can see in the C column there is two nan value. So if we want to the drop, so in the axis one is equal to basically taking the column, so what they're doing that they are just basically drop the C column. So A and B column there is no missing value, they are taking all the values here. In axis 0 is basically in the row position. In the row position, axis 0 is equal to row position they are checking here. In the 1 0 1 2 there is no missing value, so that's why they are giving all the values here. So if we see in the original data set, in the row wise, if we are just checking it here, that in the third and the fourth position there is the missing value, so that's why they are just removing the third and the fourth position. They are just removing third and fourth position. Then there is the filling. Fill any values with 0. Fill happens on original df. How we can the fill? If there is any missing value, the nan value, we can fill by 0 or any value. So how we can do that? We can just write down the fill any function. If I just write down df.fillNA and if I am passing the 0, then you can see the data frame is just filled by this nan value is filled by 0. If I am passing that any value, suppose I am taking the 2, so you can see that that value is just filled by the 2. Now forward filling and the backward filling, these two function is basically not working in the corporate world. But if you want to know in depth, so just remember one thing guys, df.fillNA function, basically what they are doing that whatever the previous value, whatever the 5 is the previous value, these two position is actually the missing value. If I want to fill up with the previous value like the 5, then I can use df.fillNA. FillNA method is equal to ffill. Then if I just run the program, then we can see they are just taking the previous value and they are just fill this to nan value position. And B fill means backward filling. What is the backward? Backward it is already nan, so they are filled with from the back side. If I run the program, you can see that from the back side they are taking nan value. These two for your knowledge you can just keep it in mind, but this two has no original implementation in the industry. Now that is the mean value. We can fill it by the mean value. How we can do that? We can just use passing that df.fill in a function, and I just write down df.mean function. Mean is basically the average. What is the average in the C column? 5 plus 5 plus 5, 15 divided by 3. That is the basically the 5. Then they are just taking the 5 as a mean value, and they are using this 5 here. Basically they are not taking this value automatically. They basically do 5 plus 5 plus 5, that is sum up total is 15 divided by 5, that is equal to 15 divided by 5 is equal to 15 divided by 3 is equal to 5. So the mean is the 5, so they are just filling the nan value with the mean value, that is the 5. Then importing and the exporting data. How we can import the data in the Pandas? If we just write down the pwd, so if you run that program, you can see this is basically gives the exact location in which directory basically you are working. I am basically working users within Pinakishing Roy and within desktop or within PyData nodes, and I am using the Pandas, so that's why they are giving the exact location. And to write to export any of the file, I already have the iris file dataset. This is the very well-known dataset. You can just type it in the Google, the iris dataset. You can just find it, this dataset in the Kaggle and Hugging Face as well. So I just downloaded it from there, from the Kaggle. I just keep it inside here, PyData nodes in Pandas. I have the iris dataset. This is the iris dataset. This is basically the iris dataset. You can see it here. And if you want to import this kind of iris dataset, how you can do that? How you can do that? So you have to use data is equal to pd.read excel file, because this is the Excel file. So I am using this function pd.read excel file. So I am giving the location, this one. So after that I just print the data. So if I run that program, you can see easily this data frame is already commit here. So this function read underscore excel, if it is the CSV file, so in that case I can do read underscore CSV. So after that we can just give the location, then automatically this file will be imported in this way. Panda will help you to import this one. And guys, just remember data.head 5, that means basically if I am using the by default, if I am not using the 5, by default they are taking the 5 dataset from here, from the starting point. And basically tail function that basically gives the by default the 5 index or the 5 point, it will be there from the last, the tail function that gives. So if I need the head function, head from the starting of the dataset, if I need the 10 dataset, if I am passing the 10 value, if I run the program, we can see from the head function they are giving the 10 value, 0, 1, 2, 3 till 9. This is the 10 value. If I need the 50 value, I can pass it 50. In the tail function, basically it also gives the tail function from the last the dataset. They are also giving the 5. If I need the 10 dataset from the last of the total whole dataset, if I'm passing the 10, then we can see that from the last they are also giving the 10 dataset in here. Or you can see the data.to excel file, and I'm passing the dataset name or the file name. By in this way also we can export the any Excel file here. But guys, remember most of the time it can throws error. So to avoid the errors, better to use the whole path of the dataset or the location of that dataset. How we can do that, I already explained in this program. If I'm using that one variable data pd.read excel, I am passing the exact location of the file, then it will give automatically the dataset or the export or the import of that dataset in your workplace. And that's all guys. Thank you so much, and please stay tuned for the PyData series 2. Thank you. Wish you all the best.